Right. Hello everyone. And okay, so hello, Sean.
Hi. I've got a strange background from what I was doing earlier on today.
Universe. Sounds amazing. So yes, hello everyone. Sean is our designated safeguarding lead for the university and for the for the physics department. Yes, if I understand correctly. Yes, and just a few words from Sean before we start. So please welcome.
Yes, yeah, very briefly. I just wanted to make sure I've introduced myself. So I'm Sian, as Vlad said. I've been a Department of Physics for about 12 years. So as a designated safeguard lead, I am your contact if you have any worries or concerns. And actually, if you have safeguarding concerns, you can speak to a number of people. So your tutors might be somebody you want to talk to about. But also if you want to talk to the team leaders, so Vlad and Rachel, they're there, they're trained in safeguarding. So if you have any concerns about anything to do with people in your group or your tutor, then there's always somebody to talk to. We don't imagine this happening, but it's just so that you know that there's a team there who are sort of ready to look after you. So you can contact me. I will put my email in the address. It's just a generic safeguarding one. So there's either me or a team member that will pick that up, and we will try and get you the help that you need if you need to talk through anything. So that was it really. And you will get to see me again. I will be popping into your tutorials in the new year. So I will just be there to see how they're running, observe for a bit. I'm always really impressed with how hard you're going to be working and all the physics you're going through. So you'll see me again. That's it really. So thank you. I think you might be muted. I've confused you, haven't I?
Hello.
Coming up. There you go.
I wanted to start today by asking you all a question about what you know about vectors. And this is a question only for the year 10s here. So first I'll ask you. So if I say, if I share my screen, so. Okay. Doesn't like Zoom for some reason. Okay, so you should be seeing my screen. So if I ask you, when I say translation by vector, 3, 5. Do you understand what this means? Only for the year 10s, yes or no? Yes, okay. And do you study it in year 10 or year 9 or earlier? When did you study that? Which year? Because we are preparing the next assignment for you earlier. Okay. Year 9. Okay, a little bit in year 9 there. Right. And a year and the same question for year 11s. Do you know what this means? Translation by vector 3, 5. Okay, okay, excellent. That's what I suspected. Okay, thank you. And so you understand what column vectors are roughly. Okay, nice. Okay, so today we're going to talk about physics, and we talk about SUVAT again. And so recap SUVAT. So let's write out assessment. Okay, I see. You told yourself. And okay, recap SUVAT. So first of all, what is SUVAT? We have 4 SUVAT equations that you need to know. In GCSE, you're only given 2 for some reason. And they seem a bit random, random choice. The Suvat equations, and we have S is displacement. So the first equation is V equals U plus AT, which often is written as A equals V minus U divided by T. And this equation contains no S. The second Suvat equation is S equals U plus V divided by 2 multiplied by T, which makes sense that the displacement, the distance traveled, is the initial velocity plus the final velocity. So it's the average velocity multiplied by time. So this equation contains no acceleration. The third Suvat equation is S equals UT plus 1/2 AT squared. Please refer to my previous webinar if you want to know more about the Suvat equations. This is just a reminder for you. There's no V in this Suvat equation. And 4, V squared equals U squared plus 2AS. Okay. And this equation contains no T. Right. So these are the equations, and just S is displacement, U is the initial velocity, V is the final velocity, and A is the acceleration, and T is time, of course. Now, in GCSE, you're given these two. You're given this one and this one. These are the GCSE ones, and the other two are introduced at A level. There's no reason why we can't introduce them now, because they're just equations which you need to be confident with using, and ideally learn them. Right. So how do we approach any question on Suvat? And just a reminder, Suvat only works if acceleration is constant. So Suvat only works if acceleration is constant. This is important to understand. Okay, so how do we use Suvat? So a particle moves along a straight line with constant acceleration from point A to point B. So when you do a physics question, it's always good to draw. So we move from point A to point B, where AB is 48 meters. At A, the particle has speed 4 meters a second. So assuming it's moving that way. It doesn't specifically say that it's moving that direction. So actually, you know what? We might be cheeky and try the opposite thing. Okay, 4 meters a second. And at B, it has speed 16 meters a second. And find the acceleration of the particle. So, well, we can see that its speed was 4 and now it's 16, so it's accelerating. Yeah, so it's accelerating, and the acceleration is question mark. So how do we do Suvat? So we put A. So we write down Suvat, and S is 48 meters. 48, that's the distance. I'm not putting units because units are obvious. Yes, 48 meters. I'll just write meters here. I won't normally put the units. U is 4. That's the initial velocity, 4 meters a second. Final velocity is 16. meters a second. Acceleration is question mark. And time, well, we don't know time, and they're not asking for time. So we just cross it out. On a scale of 0 to 10, how much sense does it make so far? We're talking about problem 2. Makes perfect sense. If it's not a 10, can you tell me what is the small part that you're not sure about? Why is it not a 10? Somebody speak up. You can use the microphone. I'm happy for people to use the microphone. So something is moving from A to B. At A, it was moving at 4 meters a second, and then it speeds up as it goes from A to B, and at B, its speed is 16. Okay, no one. Okay, no one's saying. All right. Anyways, because we don't have t and we're not interested in t. We choose the Suvat equation that does not contain t, which is the last one. V squared equals u squared. V squared equals u squared plus 2as. This is the equation that does not contain t, and all we need is to substitute the values. So v is 16 squared equals 4 squared plus 2 multiplied by a multiplied by 48. So 16 squared is 256. Yeah, should be. Minus 16 equals 2 times 48, that's 96a. So 250, that's 240, 240 divided by 96, and that's equal to a, which is 2.5-ish. 240 divided by 96. Oh, 2.5 exactly. Equals 2.5. 2.5 meters per second squared. Right. Interestingly enough, like this question has a trick up its sleeve. The answer would not change if initially the particle was moving left rather than right. Okay, so acceleration is 2.5 meters per second squared. So you could either start at 4 and accelerate from A to B, or you can start at 4 meters a second in the opposite direction with the same acceleration, well, minus 4 meters a second. You will slow down and then re-accelerate back, and you would still pass point B at 16 meters a second. Okay. That's quite interesting if you think about it. But we're going to be sane people, and we'll just assume that it's moving to the right initially. Although the answer is still going to be the same. Question B. For question B, we do the same thing. Question B. So I'm going to do very similar questions today. Suvat. Now, S is still 48. Now we're looking for time. So U is 4, is 16. Acceleration is 2.5, and time is question mark. So now we can use any equation that we like. So I'm going to use the simplest one. I'm going to use acceleration equals v minus u divided by t. So 2.5 equals, this is the simplest equation because it contains no squares at all. 2.5 and it's equal 2.5, which is v minus u, so 16 minus 4 divided by t. So t is equal to 16 minus 4, that's 12. 12 divided by 2.5 times everything by 4, so 48 divided by 10, which is 4.8 seconds. So it takes 4.8 seconds. However, if it was moving, initially it was moving in the opposite direction, the answer would be different in this case. So t is 4.8 seconds. Okay. How well do you understand on a scale of 0 to 10, please? The solution? Okay. Right. So if you're moving in a straight line with constant acceleration, just use Suvat equations, and that's it. There's nothing extraordinary here. You just need to write down Suvat and write down the equation. So let's do another one. A stone is sliding across a frozen lake in a straight line. So straight line, a stone. The initial speed of the stone is 12. So 12 meters a second. The friction between the stone and the ice causes the stone to slow down at a constant rate. So acceleration, it's backwards. It's slowing down. So acceleration is minus 0.8 meters per second squared. Find the distance moved by the stone before coming to rest. So at here, the stone is at rest, so 0 meters a second. So initial velocity is 12. Final velocity is 0. Acceleration is minus 0.8. And the displacement is question mark. Okay, so somebody help me out. Somebody help me to solve this. Help me solve this. Well, not somebody, everybody. Everybody, write out Suvat and write down the answer in the chat once you are done. Okay, you're in the car. All right. I hope you're not driving. Right. So S is question mark 90 seconds. 90 meters. Meters or seconds? U, initial velocity is 12. V is 0. Acceleration is minus 0.8. And T is, oh, they're not asking for T. So we cross it out. So we need the equation without the T. So that is V squared equals U squared plus 2AS. All right. Anyone else? Do you get the same answer? Does anyone else get 90? Did anyone else get something other than 90? I'll wait another minute. 90, nice. Okay, so it seems like the answer is 90. So V squared, this is 0 squared, equals 12 squared plus, excellent, 2 multiplied by minus 0.8 multiplied by S, which is unknown. So S is equal to minus 144 divided by minus 1.6, and 144 divided by 1.6 is 90 indeed. 90 meters. Excellent. Right. The speed of the stone at the instant where it has traveled half of the distance. Okay, so we write down another suvat. Suvat. So if it traveled half the distance, it has traveled 45 meters. Initial velocity is still 12 meters a second. Final velocity is question mark. This is what we are looking for, v. Acceleration is minus 0.8 meters per second squared, and t is, well, we don't care about t. So we use the same equation, the one that does not contain t. So v squared equals u squared plus 2as. And that gives us, well, v squared is 144 minus 1.6, so 2 times 0.8 times 45. 1.6 times 45, that's 72. 144 minus 72, 72. So v squared is 72. So v is root 72, which is 6 root 2, 6 root 2, which is 8.49 meters per second. That's the speed of the stone, which is sliding across a frozen lake. Okay. So let's do two particles. Two particles P and Q are moving along the same straight horizontal line with constant acceleration, 2 and 3.6 meters. Constant accelerations. Okay. So we have a straight line. We have stone number 1. Well, P and Q. P and Q. P is traveling at, well, 2 meters per second squared, and Q is accelerating at 3.6 meters per second squared. At time t, 0, P passes through point A with speed 4 meters a second. Right, so point A, this P passes at speed 4 meters a second. 1 second later, Q passes through A with speed 3 meters a second. 3 meters a second. Moving in the same direction as P. Write down the expression for the displacements of P and Q from A in terms of T, where T seconds is the time after P has passed through A. Yes, the webinar will be available on YouTube. All my webinars are available on YouTube, except when I mess up and if I get to record or something else happens. Okay, now they are asking in terms of t, which is quite interesting because that's what we were talking about, that it's a function of t. And so let's start with P. P is simple. The displacement of P as a function of time, the displacement of P, is the okay, that's fine. Is the initial displacement, which is 0. Well, we can say that the point A has a coordinate 0. Yeah, because why not? We're not, and this is x. This is the x-axis, and this is coordinate 0. So the initial position of S is, well, its displacement is, we're using the third Suvat equation. And we're using the sort of the modified version of that. So S is ut plus 1/2 at squared. So S, position of particle P, or the displacement of particle P, is the initial velocity multiplied by time plus 1/2 acceleration multiplied by t squared. And I can say that u is 4 multiplied by t plus 1/2 multiplied by 2 multiplied by t squared. So that simplifies to 4t plus t squared. Now the position of particle q of t is the initial velocity, which is ut plus 1/2 at squared. Its initial velocity is 3. Now the time of movement is 1 second less than for particle p, because it passes a second later. So it's going to be t minus 1 plus 1/2 multiplied by 3.6 multiplied by t minus 1 squared. So we can simplify this. This is going to be 3t minus 3 plus 1.8 open bracket t squared minus 2t plus 1. And that's going to be 3t minus 3 plus 1.8 t squared minus 3.6 t plus 1.8. And finally, it is 1.8 t squared minus 0.6 t minus 1.2. Looks like it. So that's what we've done. We've written down the expression for the displacement as a function of time. Same here. Displacement as a function of time. This could also be written as the position, because displacement because the initial position is 0. I've shown you this before. Displacement is defined as the current position minus the initial position. So displacement SP of t is okay, SP is 4t plus t squared, but this is x minus x0. So this is xp of t minus x0, which is 4t plus t squared. So, but this is x0 is 0, and because initially it is at position A. So xp of t is equal to 4t plus t squared. And similarly, we can write down that xq of t is 1.8 t squared minus 0.6 t minus 1.2. Okay. The significance of that, it gives us the position at any given moment in time. That's what I was talking about last week. No, 2 weeks ago. Sorry. Anyways, the next question, B. So this is question A. Now we can do question B. Find the value of t where the particles meet. When the particles meet, their displacements are the same. So when particles meet, SP is equal to SQ. And that means 4t plus t squared equals 1.8 t squared minus 0.6 t minus 1.2. So this becomes 0.8 t squared minus 4.6 t minus 1.2 equals 0. And I'm just going to be a bit lazy here. I'm going to find it using my calculator, my Casio calculator. So it's 3, 0.8 minus 4.6 and minus 1.2. So 6 and T1 is 6 seconds. And T2 is minus 0.25 seconds. Both of them kind of make sense because minus 0.25 seconds is when if the time goes backwards, because you can see that P is moving faster than Q. So P overtakes Q somewhere here, like at time minus 0.25 seconds. But we're not interested in that. We're not interested in what happens then. We're interested that they meet somewhere here, somewhere along the line where T is positive. So this makes sense, but it is not the solution. Not a solution. The T is 6. They meet after 6 seconds. So the answer is 6 seconds. 6 seconds. Find the distance from point A where the particles meet. Well, to do this, we just need to find S, right? We need to find the displacement. The displacement S of 6. We either need to find S of 6 of P or SQ of 6. And they won't be the same because they meet. So SP of 6 is going to be 4 times 6 plus 6 squared. That's 24 plus 36, 60 meters. And SQ of 6 is 1.8 multiplied by 36 minus 0.6 times 36. Oh, times 6, sorry. Times 6 minus 1.2, I suspect. So 1.8. Oh, it must be, unless I've done something terribly wrong. 36 minus 0.6 times 6 minus 1.2. 60 meters. So they meet 60 meters down the line. 60 meters. Okay, so how well do you understand this question? On a scale of 0 to 10, please. Anything confusing? Anything I can help with? Slightly less. I know it's slightly confusing with the equation of motion. Something you are probably less familiar with. The equation of motion gives you the position at any given moment in time. Okay. Now, when you throw something, it falls with constant acceleration. Okay. And okay, no. Here it is. Okay, so this was a couple of years ago. I've taken 2 balloons, and this is a 800-gram balloon, and this is a 1.6 kilogram balloon. So this is two times this balloon, so 2 times bigger. These are water balloons. And I'm going to drop them from the roof of Manchester University. So this is the small balloon, this is the big balloon, and I'll playback speed. Let's make it slow, and look what happens. Shaky camera. And you can see them falling very beautifully, falling at the same rate. You can actually see frame by frame how they fall together. It's too slow. You can see the 2 balloons just falling at the same rate. And they hit the ground at the same time. So yeah, this is me a couple of years ago having fun with balloons. Do try this in a safe environment. Okay, so when you're talking about falling objects, as long as you can ignore air resistance, you probably know this, that everything falls at the same rate. That means mass is directly proportional to volume, yes, absolutely. Why are you asking? Aha, well, evidently not. We've just seen the experiment. I did the same experiment with water bottles. Okay, let's come back. Water bottles and bottle drop. Bottle drop. That is me. Now they have the same volume because they're both 2-liter bottles. One is full and one is half full. So as you can see, they're falling together. Okay, I'll explain. These are literally hit at, well, almost at the same time. And you can see there's more damage caused to the full one because there's more energy. Confused.com. Excellent. Okay, so yeah, it makes sense because look, F equals ma, true. So the big balloon, is 1.6 kilograms, and the force on it is the weight, which is 16 newtons. 16 newtons, and F equals ma. And A is the force, which is 16 newtons divided by mass 1.6, which is 10 meters per second squared. The acceleration is 10. For the smaller one, the mass is 0.8 kilograms, but the weight is only 8 newtons because it's a smaller force. And F equals ma. A is F over m, so it is 8 over 0.8, which is 10 meters per second squared. So any object accelerates at 10 meters per second squared, and if you can ignore air resistance. Okay, and of course I have to show you this. So Brian Cox, feather versus bowling ball. This is probably a fantastic experiment. So this is this is what the biggest vacuum chamber on Earth. I believe it's the biggest one. And they are dropping the bowling ball and the feather from about a few meters. In a vacuum, the feather and the bowling ball will fall at exactly the same rate. But of course, you can see that the bowling ball has more energy, can cause more damage. Okay, can cause more damage, and yeah, so that's about it. Okay, so do watch these videos. No, at least the last one. It's quite fascinating. That means you can use SUVAT. For any falling object, you can use SUVAT. You can use SUVAT for any falling object. You can use SUVAT or a falling object. Where acceleration is, well, typically we use -10 because it's down second squared. When we are doing a SUVAT, we always choose a direction which is positive and or the opposite is negative. So up is normally positive and down is negative. So acceleration is if up is positive, and +10 if down is positive. So it's up to you how you do it. So problem 5, a well is 50 meters deep. A stone is released from the rest at the top of the well. Find how long the stone it takes to reach the bottom of the well. So you have a well, which is 50 meters deep, and you drop a stone. Maybe. I'm not sure. I'm not sure it's 5. So the initial velocity is 0. The final velocity, well, we don't know. The displacement is 50 meters, and the acceleration is acceleration is -10. So acceleration is down. It's -10 meters per second squared. It's g, yeah. It's g, which is 10, which we take as 10. Okay, so we're at SUVAT. Now, up is positive. Up is positive. So we are falling down, therefore, the displacement is minus 50 meters because we're moving down. We've chosen, this is our choice. We say up is positive, so displacement is minus 50, down. Initial velocity is 0. Final velocity, we don't know, and we don't really care. They're not asking for it. Acceleration is minus 10, and t is question mark. So we write down the equation. The equation is S, the one that doesn't contain V, that is S equals ut plus 1/2 at squared. So S is minus 50 equals 0 plus 1/2 multiplied by 10 multiplied by t squared. There's a minus somewhere. Yeah, lost the minus 10. There's 5. So minus 50 equals 5t squared. So t squared equals 10. T is equal to 3 square root of 10, square root of 10, which is 3.16, 16 seconds. So not 5 seconds, sorry. Does that make sense? Do you understand this question? On a scale of 0 to 10, please. Okay. 3.16. Okay. You can use a simplified version. If you're falling from a zero initial, if initial velocity is 0, then S equals ut plus 1/2 at squared. So this is equal to 0. So S is 1/2 multiplied by 10 multiplied by t squared. So S equals 5t squared. You can use this simple equation to estimate. So in 1 second, if you're falling, you are falling. In 1 second, you travel 5 meters. In 2 seconds, you travel 5 times 25, what? 5 times 4, which is 20 meters. In 3 seconds, it's 5 times 9 is 45 meters. In 4 seconds, you fall 16 times 5, 80 meters. In 5 seconds, you fall 125 meters, etc. Okay, so I think it was Niels Bohr. Niels Bohr is a really famous physicist, and he was given a physics exam. In the exam, he was asked to how do you find the height of a building using a barometer? Okay, how do you measure the height of a building using a barometer? Does anyone know this story? How do you find the height of a building using a barometer? Does anyone know? Well, you know, when you go on a plane, your ears pop, right? Or if you're going up a hill or down a hill, sometimes you feel pressure in your ears. So you can working out the difference in pressure. So air pressure. So for every so 1.2 multiplied rho GH times 10 multiplied by rho 10. 120 pascals. So you measure the pressure, the atmospheric pressure at the top of the building, and at the bottom. We're talking about a tall building, and at the bottom we have the pressure P top and pressure at the bottom. So every 10 meters, the pressure, if you go every 10 meters, pressure changes by about 120 pascals. So if the pressure at the top is, let's say, atmospheric pressure is 100,000, yeah, so it's like, say it's 100,000, 240 pascals. If the atmospheric pressure is here, and the atmospheric pressure at the bottom is 480 pascals. What's the height of the building? 20 meters, yeah. That's how you measure the height of a building using a barometer. Okay, because you know that every 10 meters, so you can work out what the height of the building is by measuring the pressure at the top and at the bottom. Okay, does that make sense to everyone? Does everyone understand how to measure the height of a building using a barometer? Don't be shy to say no. I'm happy to help. Measure the atmospheric pressure, a barometer. How do you get 25 meters after finding the pressure? Well, you find the difference in pressure. Difference in pressure is 240 pascals, right? Because this is 100,240 and this is 100,480 pascals. The difference in pressure is 240. Every 10 meters you change by 120. Therefore, it's two lots of 10 meters. So it's 20 meters. Does that make sense? You can actually use the formula. The formula is change in pressure. So the change in pressure is 240 pascals, and we know that every 10 meters, the pressure changes by 120 pascals. So you need to go up by 20 meters to have a change of 240. Does that make sense? Okay. So you can use the formula. Delta P is the density of air multiplied by G multiplied by delta H. You already know this formula. You've met it. The density of air, you can assume, is approximately 1.2 kilograms per cubic meter. So if the change in height is 20 meters, so rho G, sorry, GH. So the change in pressure is the density, which is 1.2, multiplied by G, which is 10, multiplied by H, which is 20 meters, and this is 480 pascals. Okay. Now, I believe it was Niels Bohr. I might be mistaken, but it was one of the big scientists, one of the big physicists of the 20th century, and he was given this question on a physics exam, and he thought it was insulting. that he's asked that such an easy question when he was a student, of course, when he was a student. He came up with at least 20 different ways how to use a barometer. So one of them was you drop the barometer from the top of the building and you measure the time it takes to fall down to the ground. And you can use this formula, S equals 5t squared, to work out the height of the building. Okay. So drop the barometer. Number 2 was find the height of the barometer and find how many barometers you need. You can fit. Yeah. Find length of barometer and find how many barometers. Find how many times you can fit a barometer against the building. Okay, and there was many other ones, and the last one was, let's say, number 20. Go to the manager of the building and say, look, I have a wonderful barometer. This barometer is yours if you tell me how tall the building is. So yeah, and none of them had the correct answer, which was this. He was questioned, of course, why did you give such an answer? And he explained that it was so easy that he decided to come up with 20 other methods. So yeah, story about physicists being physicists. Yeah, exactly. That's what I. Oh, okay. Yeah, the manager is not interested in the barometer. Yeah, bribe the manager. Okay. Okay, so this is the this was like story time. Another one. A ball is thrown vertically upwards from the top of a tower with speed 18. So you have a tower, and it reaches the ground. Find the height of the tower. So now we are throwing something up. It goes up, and then it reaches a maximum height, and it falls back down. Now this is 18. Oh, find the height of the tower. So H is question mark. This is 18 meters a second. Oh, sorry, vertically downwards. Okay, that's boring. Okay, sorry. I've made a mistake. It's thrown vertically downwards. The speed of 18 meters a second. And it hits the ground after 1.6 seconds. All right. So I'm still gonna assume up is positive, just because I like up is positive. Up is positive. And I write Suvat. The height of the tower is H. So S is minus H. Yeah, because we're going down. Yes, we're moving from top to bottom. S is minus H. U is, well, actually, you know what? S is question mark. Let's not make it too complicated. U is minus 18 because we're throwing it down. V is we don't know and we're not interested. A is minus 10 and T is 1.6. Okay, so we need the one without V. So S equals UT plus 1/2 AT squared. There's no V. And so S is UT, which is minus 18 multiplied by 1.6 plus 1/2 multiplied by minus 10 multiplied by 1.6 squared. So 18 times 1.6 plus 5 times 1.6 squared, which is 41.6, 41.6 meters. The displacement is minus 41.6. It's negative because we're moving down. Down is negative, up is positive. So the height of the tower must be 41.6 meters. That's it. So is there anything more interesting in that? Okay. Let's build up on this. Let's build on this problem. Let's call it problem. If it was thrown up, how long? Could you also work it out since we knew the final velocity must have been 0? No, the final velocity is not 0. Okay. Final velocity is the velocity with which it hits the ground. That's a common misconception, by the way. It hits the ground and the velocity is not 0. If you ask yourself, if it was a bowling ball, would you be, because the velocity is 0, so the kinetic energy is 0, would you be happy to be on the bottom, lying down on the ground when the bowling ball hits the ground? You probably would say no, because the final velocity is not 0. Okay, does that make sense, Vishaka? If it was indeed the velocity was 0, then it would be safe. A bowling ball with 0 velocity is no danger to anyone. But it's not 0. It's actually much more than 18. If it was thrown up, how long will it take? How long would it take? Yeah. So now it is the same tower, 41.6 meters, 41.6 meters, and it is thrown up at 18 meters a second, and it goes up and then falls back down. And how long will it take? So T's question mark. Okay, so we write Suvat. Suvat S is minus 41.6. It's still that. Because we are moving from here, we end up 41 meters below where we started. That's very important. The displacement is the difference between the initial and final position, 41 meters. Initial velocity is 18. Final velocity is, we don't know when they're not asking. A is minus 10, T is question mark. So we write down S equals UT plus 1/2 AT squared. So minus 41.6 equals 18 times T minus 5T squared. And this is a quadratic. 18T minus 41.6 equals 0. This is a quadratic equation which we can solve. So for, oh no, equation 3. This is 5 minus 18 minus 41.6. So 5.2. So T is either 5.2 seconds or T is minus 1.6 seconds. Of course, the second answer does not make sense because it's a negative time. That's what would happen 1.6 seconds ago. It would be here. Like it was, this is t0, and this is where it would be. So then go up, go down. So 5.2 seconds. It takes 5.2 seconds to travel up and then down. I wonder if we can test this. Not sure, but projector. Pretty sure we can't. Yeah, the maximum height is 15 meters, unfortunately. But we can get some sort of idea of what's going on. So initial speed is 18, yeah. And if we shoot, what are we shooting? Let's shoot a, doesn't matter what we shoot, a cannonball. It's a piano. Let's shoot a piano. Shooting a piano. Okay, and we can measure the time. It's quite consistent. If we shoot from 15 meters, unfortunately I can't move it further up. You shoot at 15 meters, it takes about 4.37 seconds to reach the ground. And yeah, and of course, next assignment will be talking about this kind of motion. Projectile motion. And this is like the extreme. So you just go up and then down. It's quite cool. All right. Anyways, it's quite consistent with what we expect. So 5.2 seconds, so slightly more than when it was thrown from 15 meters. Excellent. So we found the time. Find the speed at which it hits the ground. Well, you can just use any equation to find the speed at which it hits the ground. So let's work out the final velocity then. So the final velocity, well, I'm going to use u plus at. So velocity, final velocity is initial velocity 18 minus 10 multiplied by t, which is 18 minus 10 multiplied by 5.2, which gives us 18 minus 52, which is minus 34 meters a second. You do not want to have a bowling ball traveling at 34 meters a second downwards. Minus indicates that it is down, hitting you. Let's find the final velocity here. The final velocity is u plus at, which is, t is 1.6, okay. U is minus 18, minus 10 times 1.6, so it's minus 18 minus 16, which is minus 34 meters a second. Surprise, surprise, it's the same velocity. No matter if you throw it up or down, it will still have the same velocity when it hits the ground. And that's quite a significant result. No matter if you throw up or down, and it actually comes from this equation. V squared equals u squared plus 2as. Now u squared, so it doesn't matter where it's up or down, positive or negative, it's squared, so it doesn't make a difference. U is plus minus 18, does not make a difference. All right. Okay, so we got 20 minutes left, and I really want to talk to you about the next one, problem 8. So I'll skim quickly through problem 7. A particle piece projected vertically upwards from a point X. Okay, so we draw the y-axis, point X, so point X. 5 seconds later, P is moving downwards with speed 10. Okay, so it's projected upwards and it moves down, so somewhere here, and it moves down with speed 10 meters a second. Find the speed of projection. Okay. Suvat. S is, well, we don't know. 5 seconds, we know that T is 5. Acceleration is -10. Final velocity is -10. And the initial velocity, that is the question mark. And S, we don't care. So we need a formula without S, and this is the one and only, V minus U over T equals A. So we're looking for U. So V minus U equals AT. U is equal V minus AT. So V minus AT, so that is -10 minus -10 times 5, which is 50 minus 5, so 40 meters a second. So it was thrown up at 40 meters a second. 40 meters a second. That's what we worked out. Secondly, the greatest height attained by X. Right, the greatest height means that the final velocity is 0, because at the maximum height, velocity becomes 0 momentarily. So you are talking about Suvat again. S is question mark. U is 40. V is 0. Acceleration is -10, and T is we don't care. So we need the one without the T. So it's V squared equals U squared plus 2AS. So V squared is 0 squared equals 40 squared plus 2AS, which is 2 times -10 multiplied by S. So S is 40 squared divided by 20, which is 40 times 2, 160 meters. I believe it to be so. 40 squared divided by 20. Oh, 80. That's embarrassing. 80 meters. All right, let's see if we can do this experiment. So initial, it only goes up to 30. That's annoying. Well, we can modify it. So if the initial velocity was 30, S would be 30 squared divided by 20, right? Yeah, S squared by 20, which would be 30 squared divided by 20, which would be 45 meters. So if we shoot something at 30 meters a second, it should go 45 meters. And let's see. 30 meters a second, shoot. Okay. And let's see. It took 3 seconds to reach a height of 45.87 meters. So yeah. Now, why this is not exact? Because they are using G equals 9.8. We're using G is 10. So a slight discrepancy here, but that's the idea. 30 meters a second. Okay. Finally, a graph question. You're given a graph of displacement versus time. So this is displacement, and this is time. And you know that the gradient of this graph is velocity. So let's find the velocity at different points. So velocity is gradient. So we're gonna make a table of t versus velocity, and 0, 1, 2, 3, 4, 5. So we're going to find the gradient of the graph when t is 0. When t is 0, the gradient of the graph. So let's draw a tangent line to the best of our knowledge. So I think it's probably like this. I'm going to use red. Let's use, so we draw a tangent. So it looks like the gradient of this graph at this point where t equals 0, we draw a tangent. We can work out the gradient. So this is 1. This is like 4. So the gradient is 4. So the velocity is 4. So when t is 0, the velocity is 4. Okay. So now we draw a tangent at this point. And this is going to be like this. And we find the gradient. This is 2, this is 1. So the gradient is 2. At point t equals 2, this is this point. This is the top point. And the gradient is 0 at this point. And I think you can spot a pattern here, because the next point is this. It looks like the gradient is -2. So the gradient is -2. Gradient is 4, gradient is 2, gradient is 0. -2. Then we extend this to get, well, it looks like it's 4, -4. Gradient is -4. -2, -4. And the gradient at point 5, well, looks like 7, -7. -7. I mean, from the pattern, I can probably guess that it's going to be -6. But I mean, it's really hard to draw the tangent, right? So probably -6. So let's see, we can draw a velocity time graph. So this is a velocity and this is time. And when t is 0, velocity is 4, 1, 2, 3, 4. When it's 1, 2, 3, 4, 5. When it's 1, it's 2, 2, 0, 3, 4. Yeah, it's probably -6, not -7, but yeah, that's that. On a scale of 0 to 10, do you understand how to do this? Do you understand how I did this? So I found the gradient at every single point, but it's just drawing a tangent. Yes, you draw a tangent, you find the gradient of the tangent, and you work out the speed. So I really hope you'll like the assignment. A lot of work has gone into it. And yeah, velocity, or the velocity is the gradient of the displacement time graph. And if the acceleration is the gradient of the velocity time graph, the gradient of this graph is -2. You think about it, the gradient is, so this is 4. So the gradient is -2. That means the acceleration is -2 meters per second squared. And here, velocity changes. Okay, I'm slightly worried that there's very few 9s and 10s and everyone else is silent. There is a question like this, and there's an example like this in the assignment. So I hope this helps. Any questions? Any questions? Right. Okay, then I'll leave you to it. And yeah, so enjoy the assignment. And yeah, welcome. Yes, you have tutorials every week. Well, not every week. Well, you take a break for Christmas, of course, and basically you have 3 tutorials for each assignment. Okay, so you'll skip some of the weeks. So not exactly every week, but typically once a week. Typically every week. 3 tutorials per assignment. The same link each time, maybe once again on for the last week. Are you on Canvas? Make sure you send a message to Canvas. It should be the same. If you are send a message on Canvas to your tutor, and if they don't reply, well, do let us know, or just email us and we'll send you the link. It should be this. It should be the same link. Yes. All right. See you all.